everyone. Um, in this video, I'm going to present to you about my work, which is the mid-unit assignment of the Unit 3. And let's see, the first question is to describe what happens to the domain and the range of a logarithmic function under vertical reflection. So let's see my work here. I did a graph about the function, which I picked is the fx equals to log base 2x. And here it's the graph of this original function. And as we can see, the domain of it's x equals to any element in real number, and x is greater than 0. And the range is obviously y is equals to all element in real number. But as we reflect this function, we just add a minus sign in front of it, and the domain, as we can see, didn't change. So as the range. So as we can conclude, the domain and the range don't change during a vertical reflection in logarithmic function. Okay, so let's see the question 2 down here. Describe what happens to the domain and range when we do a horizontal and a vertical translation to the function. And as I sketch here, this one is the original function, which is log base 2x. And when I move it to the left by 2 units, it becomes log base 2 parenthesis x plus 2. And when in this step, in the second step, the domain changed to x is greater than minus 2, because before it was greater than 0. And as we move to the left by 2 units, the asymptote will change by 2 units. So when we bring it up by 2 units, which is the vertical translation, here the third graph, the function is log base 2 parenthesis x plus 2, then plus 2. So here, as we can see, the domain, as we compare the domain between these two functions, the domains are the same as the range. So we can get a conclusion is that when the function is under a vertical and horizontal translation, the domain will change to x equals to all elements in real number and greater than b. The b, which is here, is mentioned by the vertical translation. Okay. Okay, so now we are at the question 3. Graph the function fx equals to 1 over 2 log x minus 4. So I did a graph here, which is the original function, and graph the line 1 equals to x here. That's the question A. And question B, graph the inverse function. I did it here. So as we can see, they are symmetry over this line here. And question C, determine the domain range and the equation of the asymptote of the inverse function. So question C, I did some yes, I wrote something here. The domain equals to x. Uh, so x is all elements in real number. So we can see the domain from here, from minus infinity to positive infinity, and the range as well. But the range is limited by this asymptote, which is the y equals to 0. So the range is all elements in real number but greater than 0. And the asymptote, obviously, that's the y equals to 0, which is the x-axis. And question D, determine an equation of the inverse function. So I found that the inverse function is y equals to 100 and power x plus 4. I forgot to rewrite the f minus x. Sorry, but that's the answer. That's the final answer of my question D. Okay, so thank you.